So in this video, we are going to discuss about general second order active filter with unity gain. So this general order second order filter means it is a two-pole active filter. Okay, it is also called as Salenky filter. Okay. It has an admittance like Y1, Y2, Y3 and Y4 followed by a op amp which is connected as ideal voltage follower. So you know the advantage of voltage follower, right? It has a very high impedance input impedance and very low output impedance, which will eliminate the loading effect. Okay, it will helpful to eliminate loading effect. So here we are using a non-inverting amplifier configuration in order to increase the gain and to eliminate the loading effect. So let us discuss the diagram first. So this is your Y1 and this is your Y2. Okay, and this is your still 7 minutes. Since the gain is unity, I have connected feedback like this. Okay, and this is your Y4. So this is a structure of second order active filter. It's under structure. Yeah. Well, we have two nodes. Let me take that is VA and VB. Okay, and I am going to apply the Kirchhoff's current law. Okay, so at this point I can write V in minus VA. V in minus VA divide by resistance, you will get current, right? So instead of resistance I am using a admittance. Okay, so this is your incoming current that is equal to outgoing current. Okay, so this is your incoming current and this is your outgoing current. So outgoing current I can write it as VA minus VP into admittance plus VA minus Vout, right? VA minus Vout into Yt. Clear. So this is your first equation. Next is second equation. Okay. For the second loop, I can write it as VA minus VB into Y2, that is equal to VB Y4. Okay, so this is your second equation. So if this point is VB, this point also it is VB. So here VB is equal to Vout, right? So VB is equal to Vout. So you substitute here. Okay. So what I can do? One part. So here I can write that VA I2 is equal to VB Y4 plus Y2. So VA is equal to VB Y4 plus Y2 divided by Y. So let me take the first equation. V in Y1 minus VA Y1, that is equal to VA Y2 plus VA Y3 minus VB Y2 minus V0 Y3. So V in Y1 is equal to VA of Y1 plus Y2 plus Y3 minus V0 of Y2 minus Y3. V0 V0 if I take this one as minus plus, right? So what is the value of V0? VA is equal to Vout V0 Y2 plus Y4 by Y2 into Y1 plus Y2 plus Y3 minus V0 Y2 plus Y3. So I can write V1 Y1 Y2 is equal to V0 Y1 Y2 plus Y1 Y4 plus Y2 square plus Y2 Y4 plus Y3 Y2 plus Y4 Y3 minus Y2 square minus Y3 Y2. So here Y3 Y2 get cancelled out, Y2 Y2 get cancelled out. So I can write V0 by V. V0 by V is equal to Y1 Y2 divided by Y1 Y2 plus I can take Y4 common from this. So Y1 plus Y2 plus Y. So this is nothing but H of S. Okay. So in this, if I substitute y1 and y2 is equal to 1 by r1 and 1 by r2, and y3 and y4 is equal to sc1, sc2, sc3, comma, and sc4. It becomes a low pass filter. So the low pass filter will pass only the low frequency signals, and it will reject the high frequency signal. Okay. So second order low pass filter with unity gain. So I can substitute here. I need to substitute 1 by R1 and 1 by R2, right? Y1, Y2. Y1, Y2 is equal to 1 by R, 1 by R. Instead of R1, I am substituting R. Okay, and Y3 and Y4 is equal to 1 SC and SC. Okay, so if I substitute in this equation, I'll get 1 by R square, 1 by R square plus Y4. Y4 is SC, 1 by R plus 1 by R plus SC3. Oh, this is 3 and this is 4. Okay. So now multiply the whole term by R square. Okay, multiply and divide the whole term by R square. You will get 1 divided by 1 plus SC4 of R plus R plus SC3 R square. So this I can write it as 1 plus SC4R, that is 2 plus SC3R. I can. So now let me take this tau 1 is equal to RC3 and tau 2 is equal to RC4. Okay. So here I can write instead of h of j omega. If I write it as in the term of h of j omega, I will get C4R plus 2 plus j omega C3R. If I take the magnitude of this value, I'll get 1 divided by root of 1 plus omega C4R better I can write it like this, 1 divided by 1 plus j omega C2, 2 plus j omega tau. This I can write it as 1 plus 2j omega tau 2 minus omega square tau 1 tau 2. Okay. So if I take the magnitude of this value, I will get it is this root of 1 minus omega square tau 1 tau 2 the whole square plus 2 omega tau. So if I differentiate this h of j omega value by rho omega with respect to omega is equal to 0 and equate it to 0, you will get the values like this. This I can write it as 1 minus omega square tau 1 tau 2 the whole square plus 2 omega tau square whole square minus 1 by 2. So if I differentiate this one, 0 is equal to minus 1 by 2. 1 minus omega square tau 1 tau 2 the whole square plus 4 omega square tau square. Okay. Minus 3 by 2. Okay. Into. So if I differentiate this one, I will get two into 1 minus omega square tau 1 tau 2. Okay, minus 2 omega tau 1 tau plus 8 omega square omega 8 omega tau square whole square. At that. So this I can write it as so in this whole term I can substitute omega is equal to 0. So if I substitute omega is equal to 0, or this whole term they can become 1. Okay. So only this term will present. Okay. So if this is this alone will present, I can write minus 4 omega tau 1 tau 2 into 1 minus omega square tau 1 tau 2 plus 8 omega tau 2 square. Okay. So here I can take 4 omega tau 2 common. If we take that one, I will get minus tau 1 into 1 minus omega square tau 1 tau 2 plus 2 tau 2 square.
Don't wait so the telephone in me. Watch me.
So this I can write it as 4 omega tau 2 minus tau 1 plus tau 1 square omega square tau 2 plus 2 tau tau 2 square, right? So if I equate this one, I will get tau 1 minus tau 1 plus 2 tau 2, that is equal to 0. So 2 tau 2 is equal to tau 1. So what is the tau 2? I can write it as 2r C4, that is equal to r C3. So if I solve C4 is 2, C4 is equal to C3. So substitute in this equation, okay. Substitute in this equation. Prime divided by root of 1 plus so 1 minus omega square is tau 1 tau 2 the whole square plus 2 omega tau 2 the whole square. So this is your first equation. This equation, this one you have to substitute instead of tau 1 you have to substitute 2 tau 2, okay. So if I substitute tau 2, before that one if I apply, I am going to apply a minus b the whole square formula. So if I apply a minus b the whole square formula, I will get 1 minus 2 omega square tau 1 tau 2 plus omega square tau 1 tau 2 the whole square, plus this I can expand as 4 omega square tau square. Now I am going to substitute this tau 1, so it becomes 4 tau 2 square, okay. So these two get cancelled out, so you will get this equation. And here also I am going to substitute instead of tau 1, I am going to substitute 2 tau 2, okay. So this I can write it as h of j omega is equal to 1 divided by root of 1 plus 4 omega tau square the whole square. That should be equal to 1. I need to get 1 divided by root 2. So if it is root 2 means this whole term should be equal to 1. So I can write like this, okay. So this omega tau square tau 2 is equal to, I can write as 1 divided by root 2, okay. So what is tau 2? Tau 2 is r C4, okay. So if it is 3 dB value, the omega value should be equal to 1 divided by r. So I am going to equate this 3 and 4, okay. So if I equate 3 and 4, I will get 1 divided by RC is equal to 1 divided by root of 2 R C4. So from this one I can write the C is equal to 1 root 2 of C4. So C4 is equal to 1 by root 2 of C, that is equal to 0.707 C, okay. So we know that C3 is equal to 2 C4, so that is equal to 1.41 C, okay. So now in this equation I am going to substitute instead of omega I am going to substitute 2 pi f tau 2. Tau 2 is nothing but r C4, okay. So C4, I know that C4 is equal to C divided by root 2, right. C4 is equal to C divided by root 2. So if I take whole power 4, I will get this 4 and root 2 get cancelled out. So I will get this equation. So from this I can write, if I substitute Fh is equal to 1 divided by 2 pi Rc, I will get 1 h of j omega is equal to 1 divided by root of 1 plus f divided by Fh power 4. Okay. So if I draw the equation, if I draw the graph for this is 1, so it will get down when it is 3 dB. So the 3 dB value is nothing but Fh. Okay. So Fh value is nothing but 2 pi Rs. So here in the equation I can instead of y1 I can write r, and y2 I can write r, and for y3 I can write it as SC3, and y4 I can write it as SC4. Okay, that is nothing but I can connect capacitor here. Okay, I'm going to connect a capacitor, that value is C3 and C4. Here resistor value, that is nothing but R and R. Okay. So this Y4 value, so this capacitor value is nothing but what is the capacitor value? C4 value. So C4 value is nothing but 0.707 of C, where C3 value is nothing but 1.414 of C. So let us discuss problem on second order low pass Butterworth filter. So they have given to design a second order low pass filter. They have given the cutoff frequency value as 10 kilohertz, and it is unity gain. Okay, it is unity gain at low frequency. Determine voltage transfer function magnitude. Okay, voltage transfer function magnitude LDB at 12 hertz for the filter. So they have given the value of FC, right? So we know that FC is equal to 1 divided by 2 pi RC. So if I substitute 10 kilohertz, I will get the value of RC is equal to 1 by 2 pi into 10k. That is nothing but 15.92 into 10 power minus 6. This is your RC. If R is equal to 200 kilo, this I have taken my assumption. Okay, so assume R is equal to 200 kilo ohm. Then if I substitute the value 1 divided by that is 15.92 into 10 power minus 6 divided by 200k. You will get the answer as 79.6 picofarad. Okay. So if C values we have already, if you find out what is the C4 value, C4 value is 0.707 C, right? So if I substitute this C here, I will get 56.3 picofarad. Okay. So likewise, what is C3? C3 is 2 times the C value, right? C4 value. So that is nothing but 113 picofarad. Okay. So next they have asked you to find the value of H of JF, right? That is a magnitude value. That is nothing but 1 plus F by FH of 4. Okay. At F is equal to 12 hertz, right? So you substitute this value 1 divided by root of 1 plus 12 divided by, what is FH value? FH value is 10 into 10 power 3, right?
Everything.
Say this is nothing but 10 kilohertz, okay? At 10 kilohertz. So if it is 10 kilohertz, what is the value? So if I solve this one, I will get answer as 0.5704. Okay. So this is a magnitude value, so it is always a positive value. So if I find 20 log of, they have asked you in terms of magnitude. So 20 log of 0.5704 is minus 4.88 dB. Okay. So if that is the case, I can draw the circuit. Okay. So this is your R. Okay, that is 200K. So this is your VI. And this is your C3 value. So what is C3 value? This is your C4 value, right? So what is C4? C4 is 79.6 picofarad, and this one is 130 picofarad, right? So this is your general diagram. So I am going to substitute R for Y1 and Y2, and Y3 and Y4 I am substituting the capacitance value. Okay. So if I plot the values in dB, F and H of J omega, JF, that is nothing but 20 log value, yeah? 20 log of H of omega. So this 1 becomes 0, okay? And at minus, so 3, so and it get reduced at some point, right? So so this is my minus 3 dB value. So minus 3 dB value, I can find the value of FH, right? So they are asked about 12 FH. So 12 FH is nothing but minus 4.88. So here only it is minus 4.88 dB. Okay. So this is nothing but 12 kilohertz. Okay. So I hope you have understood this problem.